Hi everyone, today we are going to solve the first unique character in a string problem from LeetCode. Without further ado, let's dive in. The problem statement asks us to find the index of the first non-repeating character in a given string. If no non-repeating character exists, we return -1. And this seemingly simple task requires careful consideration of character frequencies and maintaining the order of unique characters. So how do we go about solving this problem? The solution intuition revolves around two key steps: counting the frequencies of characters and maintaining the order of unique characters. To count the frequencies, we use a dictionary data structure called char count, and we iterate over the input string character by character. And for each character, we check if it already exists as a key in the dictionary. If it does, we increment its frequency by 1. If it doesn't, we add it as a new key with an initial frequency of 1. This process allows us to efficiently count the frequencies of all the characters in the string. But how do we determine which character is the first non-repeating one? Here comes the second step: maintaining the order of unique characters. We use a list called unique chars to store the unique characters in the order they appeared in the original string. Whenever we encounter a new character, we add it to the list. And by the end of the first pass over the string, we have two important data structures: char count, which holds the frequencies of characters, and unique chars, which maintains the order of unique characters. In the second pass, we iterate over the unique chars list. For each character, we check its frequency in the char count dictionary. If the frequency is equal to 1, it means the character is non-repeating. At this point, we have successfully found the first non-repeating character in the string. To maintain the index of this non-repeating character, we utilize the index method of the original string. By calling s.index passing char, we retrieve the index of the character in the string and return it as the result. And if no non-repeating character is found during the second pass, we return -1 to indicate that there are no unique characters in the string. In summary, the intuition behind this solution lies in efficiently counting character frequencies, using a dictionary, and maintaining the order of unique characters using a list. This approach allows us to identify the first non-repeating character and obtain its index. Understanding the intuition behind the solution is crucial for building a solid foundation in problem solving and algorithmic thinking. It equips us with the mindset and strategies to tackle similar challenges effectively. And now let's move on to analyze the time complexity of our solution. The time complexity refers to the amount of time it takes for our solution to execute as the size of the input increases. In this case, the input is a given string. We iterate over the string twice. First, we perform a pass to build the char count and dictionary and populate the unique chars list. This initial pass takes a linear time, meaning it grows proportionally to the size of the input stream. Therefore, it has a time complexity of big O of n, where n is the length of the stream. Then, in the second pass, we iterate over the unique charge list, which contains unique characters in the order of their appearance. For each character, we check its frequency in the char count dictionary. This step also takes linear time, as we are examining each character exactly once. Hence, it has a time complexity of big O of k, where k represents the number of unique characters in the stream. Since both passes are independent, we can consider their time complexities separately. Therefore, the overall time complexity of our solution is big O of n plus k. And now let's move on to the space complexity, which refers to the amount of memory used by our solution. We use two data structures, the char count dictionary and the unique charge list. The char count dictionary stores the frequencies of characters. In the worst case, if all characters in the string are unique, the dictionary would take k entries, where k is the number of unique characters. Hence, the space complexity for the dictionary is big O of k. Similarly, the unique charge list stores the unique characters in the order of their appearance. In the worst case, it can contain k elements as well. Therefore, the space complexity for the list is also big O of k. Since the space complexities of the dictionary and the list are both O of k, we can say that the overall space complexity of our solution is O of k. Understanding the time and space complexities helps us assess the efficiency and the scalability of our solution. It enables us to analyze how our code performs with larger inputs and make informed decisions when dealing with real-world scenarios. Let's now walk through the code step by step to understand how the solution works. Well, first, we define a function called first unique char that takes a string s as input. This function aims to find the index of the first non-repeating character in the string. Inside the function, we initialize two important data structures, char count, which is a dictionary to store the frequencies of characters, and unique chars, an empty list to maintain the order of unique characters. Next, we start the first pass over the input string s. We iterate over each character using a for loop. Here's the interesting part. For each character, we check if it already exists as a key in the char count dictionary. If the character is already present, it means we have encountered it before. In that case, we increment its frequency by 1. And on the other hand, if the character is not present in the dictionary, it's the first time we have encountered it. So we add it as a new key to the char count dictionary with an initial frequency of 1. Additionally, we append the character to the unique chars list to maintain the order of unique characters. Once we finish the first pass, we move on to the second pass. Now we iterate over the unique chars list. This list contains the unique characters in the order they appeared in the original stream. And for each character in the unique chars list, we check its frequency in the char count dictionary. If the frequency is equal to 1, it means the character is non-repeating. Well, to find the index of this non-repeating character, we use the index method of the original string s. And we call s.indexPassingChar to get the index of the character in the string and return it as the result. If no non-repeating character is found during the second pass, we reach the end of the function and return -1 to indicate that there are no unique characters in the string. And that wraps up our tutorial on solving the first unique character in a string problem from LeetCode. Remember, problem solving is not just about finding a working solution, but also about optimizing it for time and space complexity. I encourage you to continue practicing and exploring more LeetCode problems to sharpen your problem-solving skills. LeetCode offers a wide range of coding challenges that cover various algorithms, data structures, and problem domains. Each problem you solve brings you closer to becoming a more proficient programmer. And if you have any questions, please leave a comment, and also please subscribe to my channel, like the video, and click the bell icon on to receive the latest updates. Happy coding, and thanks for watching. Goodbye.